So for 9a, what is the direction of the current flowing through the resistor? What is the magnitude of this current? As you can see, the current flows from the positive terminal with the high voltage downward through the resistor to the negative terminal with the low voltage. Now to find current, we can use the formula I equals delta V over R. But we don't have R yet, so we need to solve for it. You can solve for resistance using the formula resistivity times length divided by the cross-sectional area of the cylinder in this case equals the resistance. So if we plug in the numbers, that would be 6 times 10 to the negative 5 ohm meters times 0.015 meters divided by pi times 0.0004 squared. And this will get you ohms, 0.0179 ohms. Now you can take this number and plug it back into your equation where you know that your delta V is 4.5 volts divided by 0.0179 ohms to get 2.51 amps. For 9b, we know the electrons are the actual charges flowing in the circuit. In what direction do the electrons flow through the resistor? How many electrons per second flow through the resistor? So we know the electrons actually flow in the opposite direction of current. So the electrons flow upward through the resistor. To get the number of electrons flowing through the resistor per second, we divide the current that we found previously, 2.51 amps, by the charge we know electrons have, which is 1.6 times 10 to the negative 19th coulombs, which will get us 1.57 times 10 to the 19th electrons per second.
So for part C, it asks, what is the direction of the electric field in the resistor? How do we know this? So we know that electric field flows from high voltage to low voltage. So it's going to flow this way through the circuit, meaning that it will flow downward through the resistor. So part D asks, what is the magnitude of the electric field in the resistor? In order to find the electric field, use the formula E equals negative dV over dx. And we know that our dV value is 4.5 volts and our dx is the length, which is 0.015 meters. So we plug that into our formula and we get E equals negative 4.5 volts over 0.015 meters, which will give us 300 volts per meter. And that would be negative, but since we are just asked about the magnitude, it will be a positive 300 volts per meter because you will take the absolute value.